Right, this is section 5.2 in your textbook. It's special products. So we touched upon this yesterday. I actually showed you guys a couple examples where we did x plus 3 squared. Or sorry, we did a binomial squared. So the first thing we wanted to do to show that is just expand that squared. We know when anything is squared, it's just itself times itself. All right, so if we do that, we use our rule of FOIL or distributive property. We're distributing the first term to this binomial and the second term to this binomial. What we get is x squared plus 3x plus 3x plus 9. So that's review from yesterday. No problem. Doing the same thing here, we expand it to 2x plus 2 times 2x plus 2. And we multiply it out and we get this term here. Okay? So what we notice then is there's this pattern that's happening. Okay? There's this pattern in the middle. These two terms are always the same. Okay? And that's because that happens whenever we have a binomial that's squared. Thanks. All right, so that pattern happening. So because of that pattern, we can actually generalize a formula for a binomial when it's squared. All right, so if we have any two numbers in a binomial, a plus b squared, rather than kind of going the long way, we can develop this formula. All right? And you'll see that this formula is consistent with each one of these expansions and simplifications that I've done. Each one of these questions I've expanded, and you can see the result is a squared plus 2a times b plus b squared. So this is a squared. A, remember, is the first term in the brackets. So it's a squared plus 2 times a and b multiplied. So if I multiply a and b, I get 3x times 2 is 6x, plus b squared, which is 3 squared is 9. Okay, so it's a shortcut. That's what we're learning today. Special products, so it's a shortcut. So same thing if we look here, a squared is going to be 4x squared. AB is going to be 4x times 2 is 8x. And finally, b squared is 2 squared, which is 4. So you can go from there right to there. So you skip 2 steps. Okay, that's kind of summary of what we're looking at today. So similarly, the same thing works for a minus b squared. Okay, the only difference then is that this sign changes from positive to negative. Yep.
So does this work with exponent higher than 2?
What do you mean?
So instead 8?
No.
No?
No, so if this was like a 3 or a 4, no. It'd be a different formula entirely. Yeah, and we don't go that far in this course. Okay, so no need to worry. All right? If there is an exponent higher than 2, usually you'll learn later we can factor it out before we have to expand and simplify. Okay? Any other questions? All right, the last thing I want to look at is what we call a difference of two terms, or a difference of squares. So if we have a term that looks like this, all right, so if our question looks like this is actually 1D from page 224. If we have a question like this, so the only difference now between the two terms is the sign. Between the two binomials is the sign in between them. So let's go ahead and expand this. We're going to use our FOIL law, or first outside, inside, last. So first term's q squared plus 11q minus 11q minus 121. what we'll notice then is the middle terms actually cancel. Okay, and this happens for every binomial multiplication when the terms are just different. The signs are different between the two terms in the binomial. So if we look at another example, this is E. Okay, so again, the only difference between them is that the sign is different. They have to be identical. They have to have an identical A term and an identical B term. All right, so now we go on ahead and expand this. We're going to get 16m squared minus 12mn plus 12mn minus 9n squared. So again, you see that these two center terms cancel. So we're left with 16m squared minus 9n squared. Okay? So we can generalize what's happening here, again, by the use of a formula. All right, so let's look at that. So if our question looks like this, we know the answer is just going to be, anybody? Generalizing now? Daniel?
It would be a squared
Yeah?
plus ab.
No?
No.
You want to try another? Try again? A squared is right. So look what's happening. We go from here to here. This is equal to q squared minus 121. 121 we could also say is 11 squared, right?
Also b squared.
Yeah, so what's this sign now? Good, minus b squared. Alright, so that's it. If we have a binomial multiplication where the signs are different between the two terms in each binomial, your answer is going to be, and they call this a difference of squares. You're going to see this later when we get into factoring. So you need to be able to, on the lookout for that, to recognize that. Okay, because when we factor, we actually go the other way. Any questions? So those are the two shortcuts that we need to recognize when we have a question that looks like that, or you have a question that looks like that, where it's just squared. Okay, you can go directly to this, and you can go directly to this. All right, let's try one more. Okay, so you can save quite a bit of time by doing this. Lucas, what would the answer be to this?
49g squared
Yeah?
minus 9h squared.
That's it. Yep. Good. That's simple. Let's see if we can find a hard one. Okay, Nicholas, try this one.
So that one?
Yep. 3a minus 4b.
Okay, so can I do it the long way, sir, not with the shortcut?
No, we're going to do the shortcut because that's what we learned today. That was yesterday, the long way. So use this formula over here, Nicholas. So you're looking at a term that looks like this, right?
Yeah.
Right here. So you want to go from that to that. So what's a squared over here?
Would equal 9a squared.
Good. Now it's negative 2ab.
So it works better if I draw it out.
Yeah, okay. Well, what's AB. Let's think about that. What's this times this?
12a, negative 12ab.
Good. Now times 2. 12 times 2.
24.
Good. Negative 24AB. And finally, last one. This term squared.
Negative 16ab.
16, just this term
Oh,
squared.
16b
16b
squared.
squared. Good. Yeah, so it's tough to kind of, if you're not familiar with the equation and you're doing it on in your head for the first time, it can be tough. It is just a shortcut, guys. So if you are comfortable always going the long route, you can do that on the test. It's not going to be marked wrong. But you need to be comfortable just in terms of saving time to do it this way, okay? So you get the hang of it with some practice. All right, it's just a bit of a shortcut. Any questions at all with difference of squares or special products? Okay, that's the end of 5.2.